Greetings and welcome to the RC Wall Vacuum channel. So today I'm going to start a new chapter in a series I've been doing on electronics for RC vehicles. Today I'm going to delve into the fascinating world of thermal imaging and some applications for RCs. I got two primary projects I'm going to be working on. The first one's going to be the do-it-yourself, and both these projects are do-it-yourself. Granted, they're a little on the high end of do-it-yourself, but they are do-it-yourself. The old adage, if I can do it, anybody can do it, that applies here. But the two projects, one's going to be a handheld thermal imaging scope for doing troubleshooting and diagnostics and maintenance on your vehicles. And the second one, which is still a few months out, is going to be a pod that basically attached to quadcopters, so you can add thermal imaging to your quadcopter. It'll be a Wi-Fi communications for both data, video back in, and then control information up to the servo to control the pitch of the camera. But anyhow, for today I'm just going to delve into the handheld imager. So in this video I'm going to go through a couple of different parts of it. I'm going to go through just some facts and figures on the infrared spectrum and how that relates to thermal imaging. Then I'm going to go through, discuss a little bit and show the FLIR microbolometer I'm going to be using. And then I'm going to go into a little bit of details of what the camera is going to be set up as. And then the final stage is I'm going to put the microbolometer sensor, set it up onto the Kraken and go from a cold start and let it fire up. You'll be able to watch to see how the thermal image starts to appear on the camera. So as everybody knows, you can go out and buy these little $30 non-contact infrared thermometers to read your vehicles, and certainly that works. You can pinpoint it in certain areas. But there's a whole other realm when you can actually see the whole thermal image of something, and just by looking at colors, you can tell if you got a hot bearing someplace, you got some driveline issues, you got brakes dragging, you got an extra hot motor, whatever the case may be. So you can go to Amazon and buy some. I've been seeing some of these thermal imaging cameras that come from foreign countries that make big claims of what they can do for a couple $100. I really don't believe it. I'm kind of a fan of the FLIR products, and I've also seen there's add-on modules for like $300 or so you can put into your cell phones. I never looked into. I don't even own a cell phone, so I don't know what the specs are on those things. But this route here, I'm going this way just because I get to learn some new stuff. So that being said, thermal imaging is kind of interesting, and actually the infrared spectrum is kind of interesting because it's the only part of the electromagnetic spectrum that part of it is particles and the other end of the spectrum is wave. It's split into three different categories. There's the far, the mid, and the near. Far is 1 millimeter to around 10 microns, and interesting enough, humans emit radiation around 10 microns. Mid's around 10 microns down to 2.5 microns. And then the near, which you're getting into the light, into the red light area, that's from 2.5 microns down to 750 nanometers. So the far end of the spectrum and some part into the mid will manifest itself as waves. And then once you go up in frequency and get into the higher, the mid range, and then go into the near side, it starts to behave like particles, photons in this example. The digital cameras have the CCD and the CMOS sensors. They're sensitive to that near infrared, and so are the night vision. The image intensifiers type night vision, but with those you can't see in total darkness unless you have some sort of a near infrared light source. And the thermal imaging is the other way around. The microbolometers are not sensitive to any kind of photons, so they're not. You can't see any light. You can take one of these sensors out and point into the sky at night with a plane's going over, and you'll see the flashing lights with your naked eye. But you look through the scope, and you're going to see the outline of the plane. You'll see the blast coming off the jets, but you will see no flashing light because there is no absorption of photons on these microbolometers. So one thing with the far infrared, it will not travel through a silicon-based glass very well. It's pretty much opaque, the glass is anyhow. So generally germanium-based glass is what's used for, like in the case of rifle scopes, for the front end lens or the objective lens. So the FLIR Lepton 3.5 microbolometer I'm actually going to use in this, it's very small. It's like the size of a dime, and it has to get put into a carrier board. And the particular one I'm using is just coming off as USB but eventually I'm going to, for the actual camera, and we go into a different breakout board. It'll have all the pins tied back to the camera module itself for all the video communications, but I'll deal with that in a couple minutes. So the actual device it's sensitive to frequencies in the 8 to 14 micron range. The resolution of this is going to be 160 by 120, which gives you 19,200 pixels. The device itself, I believe, is made of a vanadium oxide, which is sensitive to its resistance changes with temperature, and then that has to all get processed, and a lot involved with that, I'm guessing. And it's got a 57-degree field of view. And as far as the video coming out of it, it uses a part of the serial peripheral interface, which is basically a networking interface that was built up, designed several years ago for interfacing to integrated circuits on a board. But it was never really meant for high speed and high data rates. But since these microbolometers don't really have super high resolution, there's not a lot of data coming back. So there is a variant called the video over SPI. It communicates its packets of video out that way to your host processor, and then the control back to the camera is coming through another network that was developed for integrated circuits. In fact, it's called the I2C, and it stands for Inter-Integrated Circuit. That was developed, I believe, by Philips in the 80s. So they split the duty between them two buses, and depending on what I said before, what card you got, some will have a USB on them, but my prototype one's going to have the USB, and then my full developed version will use the video over SPI and I2C. So like I was elaborating on before, I was making another version. This is going to have meant to attach to quadcopters, I should say. You could also put it to terrestrial type vehicles, RC cars, and like crawlers. But there is an issue. There's like a I think it's 4.3 G shock rating on this thing. So you really wouldn't want to put it on a fifth scale flying around. At least not the way I drive. You're going to damage the thing. But it might be interesting to actually put on a little rock crawler and take it out at night for checking out wildlife, or chasing off prowlers, or even harassing all those pesky feral barn cats that hang around. So besides getting the color patterns showing the heat, there are some radiometric features that will come back with some data that you can actually utilize to calibrate it, so that in your image you see the color patterns, but then you also can flash up in there what temperature is at certain devices. So to give you an idea of the size of this thing, that there is a quarter 20 nut, and that's our device. And you can see it's pretty small, and that includes the carrier board. This one particular one has a JST connector, which is tough to find parts for. I ended up just soldering a USB cable right to the board. Like I said before, I'm going to be getting a different version of this. It has the video over SPI and I2C network connections to be able to interface to the processor. This is going to be the board I'm going to be using to process the signal. It's a Raspberry Pi 0W. It's got wireless built into it. I believe it's a single core ARM Cortex processor in there. Why they call it Raspberry Pi, I don't know. It doesn't involve raspberries or whipped cream. I'm guessing you don't want to eat it because it's going to get silicon stuck in your teeth. But well, the PyPI, I know that's a short for Python, which is the scripting language you can use to program. I'm probably going to, the scripting languages are pretty slow. I'm probably going to use a compiled language like a C++, more likely. So for the display, I'm going to be using something. So this is an OLED touch display. I'm going to be using one a little bit bigger than this. I think it's a 240 by 240 resolution. I think that it should match up pretty well. This here actually happens to be a shield attached to an Arduino board, but it'll be a similar size display. And what I'll end up doing is going through, and once I develop all the hardware and software for it, I will do a CAD model, and then I'll 3D print a enclosure for it to make it kind of like give it the handheld pistol type looking thing. So this is our rundown on some of the facts and figures and some of the details of what this thing's going to be involved. So I'm going to go over now is I'm going to set the laptop up, plug this thing in, get Flutter Lepton app up and running, and get the camera up on the laptop, and we'll fire up the Kraken and see if we can watch the the thermal image display. Maybe I'll find out I have a bad bearing in there somewhere. So I just pulled the vehicle in out of the other part of the shop. It's pretty warm out there. And you can see the vehicle is relatively warm to the rest of the surroundings back here in the other part of the shop. So I'll fire this thing up and see if it should readjust. Once it starts seeing hotter spots, it should readjust everything else to match. So let's see what happens. So we'll spin this thing around and see what else shows on as far as heat goes. Yeah, all this stuff here, I mean, there's no sign of any kind of problem down in there. Although it is there's a little bit of warmth in that section right there. You see the axle, the drive line's a little bit warmed up right down there. The pipe, obviously in the cylinder, produces so much heat that it really clouds everything up tight to the front of the vehicle. See the crankcase. You can definitely see there's a lot of heat in that cylinder and pipe, and you can see where it is too, right in the middle. It's definitely down there in the cylinder, more so than up in the head. It has the fins. And obviously see the stinger part of the pipe there. And it will rescale when I get my hand in there. It rescales how it's looking at things. You see how it changes when I pull away. I don't see any issues in the front end, the front differential. Yeah, you can see right there's the servo. You can see that. You can see the top of the servo right there. The heat signature coming off of that, and right there's the throttle servo. So that was starting to get a little bit warmer. So it definitely has potential to be useful as a diagnostic tool. Probably work better in cooler weather, but for the most part, I think this would be actually good because you can certainly spot any if you had like a bad bearing down in there, you're definitely going to see it. It's definitely going to stick out like a sore thumb. It already is showing a little bit different, the heat signature, than the surrounding on that front left tire. You certainly would see if there was a differential issue in there, you definitely would see that. And you can see up there is my CD player sitting there warmed. I'm not sure what's up with that there. It might just be a fluke of the flitter. So that's what you look like when your thermal imaging is coming off your vehicle. It's pretty hot up there in spots. So here's the thing: after it's sat for probably like 5-10 minutes, the cylinder is still glowing red hot or white hot, and there's the air intake that's nice and cool there. Let me switch modes. And that's the grayscale. I almost think that gives a better view. You spin the thing back around again. Well, look how quickly that pipe's cooled down relative to the cylinder. The cylinder is still glowing nice and hot in there, and that pipe's cooled right back down. So until the next video, thanks for watching. Adios.